For our next topic in graphical methods, we're going to look at cubics. So we've done parabolas, and the general equation of a cubic looks quite similar to a parabola. Now a cubic can either look like something like this, and it could be going the other way, or a little more like this. Now we're going to focus on this type of cubic. The other type of cubic, better dealt with in factorized form, it's easy enough to to find three values that'll hit the x-axis. It gets quite difficult to, on top of that, also have specific mins and max points that will fit the curve as well. It's possible and it's doable, but it's quite tricky, especially at level 2. So we're going to focus on the second type here, and that cubic is like your general one that looks like y equals x cubed. So y equals x cubed in general, if I did a real quick table of values, so if I did -3 through 3, so the first one, -3 cubed, remember -3 means -3 times -3 times -3, so it will stay negative. So that's -27, quite a big value. -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8, and 3 cubed is 27. So if we were to put some points on here, we've got 0, 0. I'll do the positive ones first. 1, 1 might be about here. 2, 8 would already be quite high, let's say. And then 327 is already off of my screen, the scale that I've done. And on the negative side, we've got -1, -1, so to the left 1 and down 1. -2, -8, and I'll estimate it's about here. And then -27 would also be off of my scale. So if I draw the curve in roughly, it would look something like that. And I guess it's good to label our axes, x and y. So there's a cubic in general. Now let's talk about how we could possibly move and change the shape of this cubic. So very, very similar to the parabola, y equals a bracket x minus b bracket cubed this time, because it's a cubic, plus c. So you'll notice this looks almost identical to the parabola, except for there's a cubed instead of a squared. And the three letters do exactly the same thing again. So A is controlling the shape. So a bigger value will make it even skinnier. If A is greater than 1, it's getting skinnier or thinner. If A is less than 1, but still greater than 0, so basically if A is a fraction, then it's getting wider or fatter. And if A is negative, then that will reflect it in the x-axis, so that flips it upside down. So if I did a real quick sketch here again, let's say I did this. If this purple one here is y equals x cubed, then my red one here, if I flipped it upside down, it would look like that. So that would be y equals negative x cubed, as in -1. All right, and B and C do the same thing as they did before. So B is our horizontal shift. Remember, it moves opposite to how you would think it would be. So positive moves it to the left, and negative moves it to the right. The negative in the formula takes care of it for us, though. So when we figure out the shift and we sub it in, it'll automatically change it. to the opposite for us. And C is our vertical shift. Which is normal. Moving up is positive and down is negative. So let's try some cubic questions based on that. So let's describe the cubics. The cubics. And how they differ from our standard one, y equals x cubed. Then sketch. So, first one, y equals x cubed plus 4. So how would you describe the change to this cubic? I would describe it as moving up 4, or a shift up 4. The other word is a translation. So I'm going to use shift this time. A shift up 4. So if this was our standard cubic, instead of it having the inflection point at 0, 0, it would look like that. So it's been moved up. That's at 4. I didn't mention that before, I don't think yet. So the point where it changes, so it kind of looks like a curve one way, and then all of a sudden it looks like a curve the other way. That point right in the middle here is called the inflection point. So remember, with a parabola we had turning points, or a vertex. On a cubic, it's an inflection point. So our second one, y equals x plus 2 in brackets cubed. So I would describe this one as a translation. So I could say shift or translation. Now which way would I move it? Would I move it to the left 2 or to the right 2? Which way is plus 2 in the brackets? So I'll just scroll up again. Remember, up here, a horizontal shift, positive moves it to the left and negative moves it to the right. So this is a translation to the left 2. Let's do a couple more. Alright, so the next one, y equals negative x plus 1 cubed plus 3. So this one has been flipped upside down. We have a shift. Remember, plus 1 means to the left 1, so shift left 1 and up 3. Positive 3 is up 3. Alright, now the next thing we're going to look at is modeling a cubic to some points. So for modeling, so if I'm given 2 points, and let's say I've got a curve. Once again, this is very similar to what we've just done with the parabola. So we want to consider if something looks like it's this way or that way, that looks like a ramp, or if it looks like this way or this way, and that looks like a hill. Now, if it looks like a ramp, then our bottom point is going to be our point of reference. If it looks like a hill, then our top point is going to be the point of reference. Now remember, it's not called a vertex with a cubic, that's for a parabola. Our reference point is going to be the inflection point. Now for this one, what does that look more like? Does that look more like a ramp or more like a hill? I think it looks more like a ramp. So our reference point would be this bottom one. So I would make the bottom one the inflection point. Remember, we want a reference point because we've got three letters, A, B, and C. And by picking one of them to be the reference, a reference is a point that it always goes through. So y equals x cubed for a cubic, the inflection point goes through 0, 0 unless it's been moved. So if I call a certain point the reference point, then I know exactly how it's been moved. Therefore, I get two of the letters right off the bat. I'll get B and C, and then I only have to solve for A. So, if we did an example here, well, and let's just use the one I've got above here. So let's say this point right here is negative 1, 4, and this point right here can be 3, 1. If we decide that 3, 1 is going to be the inflection point, so we would write that. So let 3, 1 be the inflection point. So therefore, that is a shift right 3 and up 1. And if we know that, then B must be equal to 3 and C must be equal to 1. So we can already substitute those into it. So y equals A bracket x minus 3, and remember the formulas are got the minus in it, cubed plus 1. Now if you remember from the first tutorial what we did next, it's the exact same thing, and it's true for all these curves. The next thing to do is sub in the other point. So far we've got a cubic with an inflection point of 3, 1, but we haven't forced it to go through the point negative 1, 4. So by subbing in the point negative 1, 4, we are making it go through that point and therefore getting the equation that'll go through those two curves. So we're going to sub in negative 1, 4. So remember, it's xy, so y comes first, y equals, so 4 equals A bracket negative 1 minus 3 cubed plus 1. So the first thing I would do is minus that 1 to the left hand side, so I get 3 equals negative 1 minus 3 is negative 4. Negative 4 cubed, remember if I cube a negative it stays negative, so it is negative 64a. And if I divide both sides by negative 64, we get negative 3 over 64 is equal to a. So therefore, y equals negative 3 over 64 x minus 3 cubed plus 1. And just like we did with the parabolas, it's nice to write the domain. Remember, this isn't a whole cubic. It's only a cubic model between these 2 points. So we look at the x values and we go between from left to right. The x values go from negative 1 to 3. So we write x is greater than or equal to negative 1, less than or equal to 3. And for all these questions, remember the arrows always point to the left and we always write it left to right. So left is the smaller number, right's the larger number. Let's do another example. It is worth mentioning that a was negative, but if I look at this, look at the way it's curving. So if we said a normal cubic curves this way, this one's kind of curving the other way. It looks like it's going that way, like that part of it. And that happens when it's been flipped. So I expected that A would in fact be negative. So that's a good thing that we got a negative value. All right, let's do another example. Let's go between 2 points, and I'll curve this way this time. So let's go between 3, 1, and 9, 14. So this time, does it look like a ramp or a hill? This time it looks like a ramp. Remember, with a ramp, we want the bottom point to be the point of reference. So we're going to let that be our inflection point. So let's let 3, 1 be the inflection point. And if it is, that means we've got a translation to the right 3 and up 1. If we've got a translation to the right 3 and up 1, therefore we know what the shift is already. B is equal to 3, C equals 1. It just equals what the shift is. So the next thing is to put that into the equation. So we get y equals a x minus 3 cubed plus 1. And once again, we're going to sub in the other point. So we're going to sub in 914. So we get 14 equals a bracket 9 minus 3 cubed plus 1. So the first thing I would do was minus 1 from both sides, which is 13. 9 minus 3 is 6. 6 cubed is 6 times 6 times 6. So that's 216. A. So the next thing I would do is divide by 216. So therefore, A is going to be equal to 13 over 216. Now you can check to see if this will simplify, but if you put it into your calculator, you'll see 13, and it does not go into 216 at all. So that's fully simplified. So therefore, y equals 13 over 216 x minus 3 cubed plus 1. So we've created a parabola that goes through the point 3, 1 and 9, 14, and it's curving the right way. So remember, this time it's positive, and normally a cubic looks like this. We've kind of modeled this side over here somewhat. Hopefully you found this useful, and this will help with answering questions on cubics.